All right, today we're doing something a little different. We're going full-on mechanical detective. We're going to pry open the heart of global trade itself, those massive, massive engines that power the world's cargo ships. And yeah, we're going to learn how to read them, not like a book, but more like a crime scene.
Seriously, just look around you right now. Your phone, that coffee you're drinking, the clothes you're wearing, I'd bet almost all of it got to you on a ship. And what's pushing that ship across the ocean? An engine. But we're not talking about your car engine. We're talking about a behemoth the size of a small building, literally 3 stories tall, weighing over 2,000 tons. It's just incredible.
So what happens if one of these things breaks down? Well, you can't exactly pull over to the shoulder in the middle of the Pacific Ocean, right? There's no roadside assistance out there. A failure is a huge deal. We're talking incredibly expensive, seriously dangerous, and it can throw a wrench in the entire global supply chain. That's why keeping these metal hearts beating is this high-stakes game of prediction and prevention. You have to be watching them constantly.
Okay, so to figure this out, we're putting on our detective hats. Here's the game plan for today. We'll look at the basic idea behind keeping these things healthy. Then we'll check out the detective's toolkit. After that, we get to the fun part, decoding the clues. Then we'll see what happens when we find a suspect. And finally, we'll wrap it up with the art of preventing the crime from ever happening. Let's get into it.
All right, first things first, the core idea here. You don't run an engine this important until it explodes. That's not how it works. The whole philosophy is something called condition-based maintenance. Think of it like a doctor giving you regular checkups instead of waiting for you to have a heart attack. You're constantly monitoring its health so you can step in before things go catastrophically wrong.
So, what does that look like in practice? Well, check out this number, 30,000 hours. That's the goal for what they call time between overhauls. See, the old way was just, okay, after X number of hours, you tear it down, whether it's broken or not. Super wasteful. But by actually listening to the engine, by monitoring its condition, you can push that overhaul time way, way out. We're talking past 30,000 hours. To put that in perspective, that is more than 3 years of this engine running nonstop. Wild.
And look, this isn't just about saving a few bucks on maintenance. It's really about safety. It's about reliability. It's about knowing that this ship is going to make it across the ocean. Learning to read the engine with your own eyes is the #1 way to catch those little problems before they become enormous, ship-stopping disasters.
Okay, so you're about to climb inside an engine that's bigger than a house. What do you bring with you? Just like any good detective, you need your toolkit. And you need to make sure the scene is secure, because when the crime scene is the inside of a giant multi-ton machine, safety isn't just a suggestion, it is everything.
So here it is, the mechanical detective's go bag. Yeah, it might look kind of basic, right? A flashlight, a mirror, a camera, but every single tool here is absolutely crucial. You need the light and mirror to see into those dark, tight corners. The camera is your evidence log. You document everything. The gauges give you the hard data. This isn't just a quick peek. It's a methodical, forensic investigation. Okay, we've got our gear, we're suited up, we are now inside the engine. And this is where the real detective work begins. Because a piston ring isn't going to send you a text message when it's feeling stressed out. Nope. It communicates in a different way. A physical language of scratches, weird colors, and different textures. Our job is to learn that language.
So, who are the usual suspects in our investigation? Well, 2 of the big ones are abrasion and corrosion. Think of abrasion as a burglar who leaves scratches all over the place. It's caused by tiny, hard junk in the fuel. Corrosion, that's a different kind of criminal. It's more like a poisoner, a chemical attack that leaves behind strange colored stains or a pockmarked, pitted surface. And that usually points to a problem with the lube oil. Okay, so you've found these clues. How do you know what's a big deal and what's not? Easy. Engineers use a super simple but really effective traffic light system. Green, yellow, red. Just like on the road, each color gives you a very clear signal about what to do next and how fast you need to do it.
Let's take a cylinder liner as our example. If you look inside and it's green, you're golden. It looks brand new, you can even see the original machine marks on it. Perfect. Now if it's yellow, okay, that's a warning sign. You might see some black gunk or some spots of corrosion. The verdict there is keep a very close eye on this. But red is bad. That means the surface is all scuffed up, it looks dull. The verdict is simple. This part is toast. It's got to be replaced now.
So,
That brings us to the next step. What do you do when you get that red alert? When the evidence is staring you in the face, you have to act. And you have to act fast. Because ignoring a red flag here could lead to a total engine failure later on.
But here's a good question. Let's say you find one small, really bad spot on a component that weighs, I don't know, a few tons. Do you have to replace the whole thing? I mean, that's a huge job. You might have to stop the ship, bring in a crane. It's a massive undertaking. The answer? Well, surprisingly, not always.
This is where the job goes from science to, well, art. A really skilled engineer can perform what's basically on-the-spot surgery. First, they protect everything around the wound. Then they'll carefully use a grinder to smooth out the damaged spot. And finally, they'll painstakingly polish it to get rid of any sharp edges. Now, this isn't a permanent fix, right? It's like putting a cast on a broken bone. It stabilizes the patient, but you're definitely going to schedule more frequent checkups after this.
Now, any good detective will tell you, you never, ever rely on just one piece of evidence. Looking at the parts, that's like dusting for fingerprints at the crime scene. But the real deep dive, the DNA analysis, for an engine, that comes from its lifeblood, the oil.
To really understand what's going on, you need to build a case over time, and that means a constant rhythm of collecting evidence. So you'll do a visual inspection, say every 500 to 1,000 hours. You'll break out the precision tools for detailed measurements maybe every couple thousand hours. But the oil, you're sampling that stuff weekly. It's a constant stream of fresh intel from deep inside the machine.
And this oil analysis is, for all intents and purposes, a blood test for the engine. It's that simple. They send a sample to the lab, and the lab looks for two main things. First, the chemical health of the oil itself. Is it still doing its job? And second, and this is the big one, they look for tiny little particles of iron. If the iron count suddenly spikes, that's your alarm bell. It means something metal is wearing down, fast. It's a clue that's completely invisible to the human eye.
So you take the visual clues from the crime scene, you add in the hard data from the measurements, and you combine it with the DNA results from the oil lab. When you put all that evidence together, you're not just a mechanic fixing broken stuff anymore. You're playing a whole different game. You're in the world of proactive health.
And honestly, if you take one thing away from all of this, let it be this. The whole point isn't just to be good at fixing things. The goal is to be an amazing detective, to find the clues before they become a crisis, to understand what they mean, and to act on them to prevent the crime, the catastrophic failure, from ever even happening. It's all about making these machines as reliable as humanly possible.
Because in the end, that's what it is, isn't it? Every single scratch, every little pit mark, every weird colored stain, it's a word, it's a sentence in the secret language of the machine. And by learning how to read that language, these engineers become translators, making sure the giant heart of global trade never ever skips a beat. And that really makes you think, doesn't it? It's not just about these giant ship engines. Think about your car or the massive server farms that run the internet. Our entire world is built on complex machines. And maybe this idea of deep listening, of becoming a detective for our tech, maybe that's the future. So the question is, what other hidden languages are our machines speaking, just waiting for someone to learn how to listen?